You guys see my counter?
Yep.
Yeah.
All right. So here we go. So like last time, I went ahead and created another 3x5, and these are questions 36 to 50. Okay. Again, I don't think there's anything here that is reinventing the wheel. So hopefully we will be able to get through this. I gotta move that mouse a second, it'll drive me nuts. Alrighty, so we're at 58, not terrible, but we could always be better. How many of you, how many of those of you that are on here right now, how many of you are everydayers with me? So pretty much everyone that's on here is an everydayer. So my next question is, has it been worth it, you think?
Yes.
Yeah.
Okay, because I'm going to be honest, I'm a little frustrated with a few of my students. You know, and granted, I understand that if you got to work or something, but if you're just sleeping in, I think you're missing the point here. Simply because, as a teacher, I really feel like there's a lot of teachers that are dropping the ball here as well, which is disappointing. You know, but if I was a student and I realized that my teacher was, I don't know, doing what he was supposed to, I would probably take the time to be here, unless I, you know, like I said, unless I couldn't. But that's just me. I don't know. What do I know? Alright, so I got 429 today. 429. And this is going to be Chem 1110. Cumulative review. And this is day 2. I'm going to put these up by days. So I don't know if anybody went and watched the last one, but I don't think I labeled it, but I will label them from now on, and we'll just go by day 1, day 2, day 3. And then I always put the date there so you have an idea. So if you were to miss one, you'll be able to go back and just pull it up by the date. Okay? Alright, so we're going to continue on here. And the next question is this. PV equals nRT. Anybody remember what that was?
That's Hertner. Pressure times volume equals some K value times. Damn. That's off.
Say that again?
It looks like the universal.
That's temperature.
I heard that. So who was that? That was a girl's voice. Who was telling me what R was? What was it?
Like the
universal gas constant, is that what?
Yep, universal gas constant. Anybody got that in their notes?
.0821.
0.0821, and that's the value of it. But there was another part of that was really important. Liters times atmosphere over moles times K. Now, is that you, Gabby?
Yeah.
Okay, why is that so important? Do you remember?
Is it because of like the way it all cancels out?
Exactly, because that tells me what units I have to be in. So pressure must be in atmospheres. Volume must be in liters. N is the number of moles. And then T must be in Kelvin. Okay? And it's simply, what do we do here? Anybody remember what we did with that equation? Was that a phone?
That was my phone, yeah.
Okay.
Sorry. Usually with this equation, they give us like 4 of the numbers and then we have to find the other one.
Except they'd only give us 3 because we already knew what R was.
Yeah.
So make sure you know that. Make sure you know what R is, okay? Alrighty, so my next thing is there are 4 types of intermolecular forces. Now, anybody remember these? There are 3 of these I think you probably should remember because we've talked about a couple of them since then. But this may be 3 chapters ago, maybe 4. Anybody remember the forces that hold separate molecules together, what they were? Okay, so I had London dispersion. You know what? Let me write these out. Give me a second. Well, let's do this. So LD was London dispersion. And does anybody remember where they fell?
London dispersion was like the least amount.
Yeah, these were the weakest. Okay, and then what was next? Anybody remember?
Dipole.
Then I had DD, which stood for dipole. And they were in the middle. Okay. Then anybody remember the other one? Main one we talked about?
Hydrogen.
Yeah, hydrogen bonding. And what do we know about that? It's got to be an F, an O, and an N, my old ET joke, right?
Yep.
And these were the what? These were the strongest, exactly. Now there is one other one that I don't even think we talked about, and it is what is called a temporary dipole interaction. And this is it doesn't matter, other than you just need to understand that there are some times where, like, if I want to get something to turn into a solid, that I've got it really cold but I can't get it to convert to a solid, I can actually pass it through a magnet, and that magnet will make the particles in there arrange themselves in an orderly fashion, and then once they're arranged in that orderly fashion, it'll allow them to bond and to solidify. But this is, it creates what's called a temporary dipole. Sometimes refer to it as an instantaneous dipole, which basically creates a charge, it allows them to line up, and then it allows them to freeze. These are, a lot like dipole, but because they're temporary, they just don't last very long. So just something to be aware of. But these are the 3 you need to know. And there, something I think we talked about quite a bit. Correct?
Yeah.
All right. Next thing we got to talk about is solubility and factors that affect it. Okay? Now, if I'm talking about a solid and I want to increase the solubility, what do? Anybody remember? If I want to increase the solubility of a solid, what's the easiest thing to do? Not a soul? Yeah, increase the T. What if it's a gas and I want to increase the solubility?
Decrease the temperature.
Decrease the temperature. That's my old fish story, right? Nobody remembers me talking about that? Oh, come on. Nobody remembers me saying, where do fish live?
Oh, yeah, I remember.
Yeah, they live at the bottom where the water's the what?
The coldest.
Coldest. Why do they live where the water's the coldest? Because that's where there's more...
Well, like there.
Yeah, more dissolved oxygen.
Mm-hmm.
So only one of you remember me talking. Man, you guys suck. Jeez. Hey, while I'm changing the page here, Did they send out the teacher video?
Yeah. I didn't send it, but it's on YouTube.
What?
I watched it yesterday.
It's on YouTube, yeah.
Oh, it is on YouTube?
Yeah.
Okay.
I can find it. What teacher video?
So, you know how some of the student officers engaged in his bad hair made him... Now, come on. That was funny. Tell me that wasn't funny. Okay. The teachers made one of those for you guys. I was in it. If you didn't notice, I thought mine was funny. Jerk. Yeah, you did. Mine was kind of funny.
The funny one was Brooke and her cat. I'm gonna say it.
Yeah, that was hilarious. This is funny.
Yeah, and I had to follow that. I think it was right after her, wasn't I?
Yeah, I thought that.
Yeah. Oh well. I didn't get to the whole thing because I was busy, but I did notice a little bit. Alrighty, so from there, what's Big M? You remember what Big M is?
Molarity.
Molarity. So, Tolman, what's molarity?
Ooh, that's a big question.
Anybody bail him out? Haven't heard Sierra today. Sierra on here?
Is that the concentration?
It is. It is. It's a measure. It is a measure of concentration. But what is it?
Over liters of solution.
So moles what?
Solute.
Moles solute over liters of solution. Right? Okay. Make sure you remember that. That's on there. Okay, here we go. My pen just died, and I missed again. One of these days. Alrighty, so moles of solute over liters of solution.
Denton, you could have just said you made it. We wouldn't have known any the better.
Yeah, but I'm honest to a fault. Just ask a couple of the parents I've had to talk to recently. Okay? It hasn't been pretty. Okay? So yeah, who can remember what they usually did here to try to mess you up? Anybody?
Solution in milliliters?
Yeah, they put it in milliliters, or they gave you your solute in what? Grams, and had you convert to moles, just things like that. Okay? Then we got to remember M1 V1 equals M2 V2. What is this for? Anybody remember?
That's for if you change your molarity or volume.
Okay, but what was the word? It starts with a D.
Dilution.
Yeah, it's for dilutions, right? Now, when we took this test, they had like 6 or 7 of these on there, but they had one question that was different. And I would ask if anybody remembers, but there was only one question on the test like this, so I'm going to show you one of those questions. It was something like this. So, given a solution of, let's say it's 1.4 molar, and you have, let's say 65 milliliters of it, what is the new molarity if you add 35 milliliters of H2O to it? Okay? Now, anybody remember this kind of question? And what makes it different?
Oh, yes, I do. It's the H2, isn't it?
What do you mean?
Like, because we have, like, I can't remember it too well, but, like, because of that 2 down there, you
No.
divide.
Okay, no, that was the acid-base ones, and that's actually a great point. That's not today, though. That's when we did titrations. We were figuring out how much acid or base was used, and that was if it was like H2SO4 or something like that. Different kind of question.
Okay.
So let me show you what we usually did here. We usually just went and figured out which one was M1 and B1 and M2 and B2, right? So like here I would say, well, that's going to be M1. That means that's got to be B1, right? Well, is that my B2?
No, you gotta add it.
Exactly. That's what was different about this. That is not my B2. It is because I'm adding that many milliliters of water, my new V2 is what? 100 milliliters. So then I was able to go, M1 is 1.4 molar times V1, which is 65 milliliters, and that's going to equal M2, which is what I'm looking for, okay? And B2 is now 100 milliliters. Now, when we usually did volume, what did we say earlier? Volume was usually in liters, right? Does anybody remember anything about this, though? Do I need to put them in liters, or can I stay in milliliters?
As long as they're the same, you can use it, right?
Exactly. Who was that?
Hudman.
Hudman, nice job. Because when I do this, my 100 mils, I'm going to divide off my 100 mils. They're going away, so they don't matter. That's going to leave my M2 as what?
.91.
0.91?
Yeah.
Sorry. Now, as I write down Tolman's answer, so I got 0.91 molar. Anybody remember something I taught you about looking at that?
Are you gonna say sig?
No, but that is a great point. It would be, let's say I did that though now. Slap that decimal right there. How many would it have?
Well, then 0.91 would work. So
It would. Why?
Because of the 1.4.
Yeah, because of the 2 sig figs, right? Now, that wasn't what I was going to say. There was another thing you could look at here. Anybody remember what it was? Nobody? Well, let's go back up here then. Let's look at my original equation. Does anybody remember what kind of relationship they have to have?
Wasn't it something like an inverse, like if one goes up, the other should go down?
Who was that?
White.
Right, great job, Ireland, exactly. These have an inverse relationship, right? So my volume went up, my molarity has to go down. Did my molarity go down?
Yeah.
Exactly. That was that one thing I said you could kind of look at to make sure you were doing it correctly. Okay?
Yeah.
Alrighty. So from there... Oh, yeah. Okay. Then we did, pH. Good old buddy pH. Now, I'm going to be honest, they do the question they ask is a little bit challenging, and it is something along the lines of this. So if I said given a pH equal to 4.4, what is well, let me ask you, what would be the hardest thing they could ask you to find here?
POH.
That'd be the hardest?
Oh, wait, no. Concentration of OH.
Yeah, what is the OH negative concentration equal to? Okay, now it's not identical to this, obviously, but it is a similar type question to this. So, who can remember how to do these?
So pH plus POH equals like 14.
pH plus POH equals 14, okay?
So you do 14 minus 4.4.
14 minus 4.4 gives me 9.6, and that is my POH, right?
Yep.
And how do I go from POH to OH negative?
Is that where you do 10 to the negative 9.6?
So 10 to the negative 9.6 is going to be equal to my OH negative. Is he right? Nobody knows?
Yes, this is what I always get wrong.
He is right? Who is that?
Russell.
Who?
Russell?
Camry?
Remember one day I kept doing everything wrong?
Oh, yeah, I remember that. Yeah, you remember this though, right?
Yes.
Okay, so what's this going to be? Somebody besides Tolman got a calculator? I'm going to be honest, that kind of startled me a little bit. Yeah.
Sorry.
Yeah, I jumped. Did anybody jump besides me?
I did.
Oh. Okay. Does anybody got this answer?
2.5 times 10 to the negative.
2.5 times 10 to the negative 10th?
Yes.
Yeah, and if we remember my little thing, that looks like it is, because it should be 10, but because that went up, that went down, right? Remember that little thing I taught you? Yeah? Okay, so half-life. Half-life equations, remember they approach this as simplistic as possible, correct? So if I said, let's see. So if I said, given 27.6 grams of a radioactive substance with a half-life of 17 days, how many grams would be left in 68 days? Something like that. Anybody remember how to do that?
Yeah, you divide 17 times 68, find out how many times it half-life.
So I take 17 divided 68.
How many 68?
So 68 divided by 17, and that's going to give me, is that 4? 4 half-lives. Okay, and then what do I do?
Then don't you do 27.6 times 1/2 to the 4th power?
Is he right?
No, you just divide it 4 times.
Or I could take 27.6 and divide it by 2 4 times. Either way, right? So what do I get here?
1.725.
1.725 grams. Anybody get that?
It's going to be like 1.73. Are we counting the days or no?
Now, usually days I would not count, but I would say probably you're right, 1.73 grams because of my 3 sig figs right there. Okay? Good job. Good job, awesome.
Thank you.
Alrighty, so next thing is nuclear equations, which I'm going to be honest, I felt like we did really well on. Nobody remembers these?
Is that where you just had to equal off the...
Exactly, that's exactly what I'm getting at, right? So if I gave you, you know what, should we make one up really quick?
Yeah.
Let's say I gave you gadolinium. Let's say I gave you GD 158 and 64, and let's say I bombard that with an alpha particle, alpha 4 and 2, right? And let's say it splits into something plus, and I'm just going to make something up here, and let's say I get out zinc 66 and 30 plus let's say get out plus I don't know. Let's say get out 2 neutrons. Neutron, and that was... Neutron was 1 and 1, right? 1 and 1?
No, because isn't one of them... Wait, no. Never mind, I'm good. Sorry.
That's a zinc. I think that works. Anybody figure out what goes in that blank? Anybody remember how to do that?
Dan, you gave us like 4 seconds.
Sorry. Hopefully somebody besides Tolman's working on this. I see a whole bunch of people over there. Hey, we're up to 60 kids. That's good. That's over half of you. Better than my freaking math kids. They're pissing me off.
1.
Because I just...
That was 2.
What do you got?
Are you doing raising Andy? Because we could have started it. I'm 2.
Oh, good. Let's do that. Yeah, let's go to 10. That's my phone. Sorry. Classroom phone here.
5.
Hey, Shay, what's up?
6.
7.
8.
It's the one that's got twins. Kyler and Brady. And I would have to pull up. If you, hold on a second. You got a twin? Yeah, you got a twin. Kyler and Brady. Okay. Yep, bye. Alright, so I don't know what number we at, people.
We're at 9.
We're at 9. Let's go to 10.
10.
Okay, so who was 3?
That was me.
Who was that?
Butler.
Butler, what do you got for me?
I've got plutonium 94. 34.
Plutonium.
I think that's right, isn't it? 94. Yeah, it is.
PU 94.
No, on the bottom. Sorry, the top is 94.
The top is 94. The bottom is what?
34.
The bottom is 34.
Yeah.
You're half right.
Yeah, I'm realizing that now.
Yeah. So what's you put the symbol for which one of these?
I put it for the top.
Top number. I need the symbol for the bottom, right? Better now than on the test, right? Who has this symbol? What's 34? Selenium. SE like that. Other than that, though, he was good?
Yep.
Okay. So, that's that. Alrighty, so... nuclear... Oh! Then there is a types of carbon question. So it's going to look like this. So it'll be like this, you know, they'll go with like, they'll say this, so like, okay, this is carbon 1, this is carbon 2, and this is carbon 3. You know, what kind of carbon is carbon 1?
Quaternary.
Quaternary, right? It's a 4 degree. Correct. What about carbon 2?
Tertiary.
Tertiary, it's a 3 degree. What about carbon 3? Also
Secondary.
secondary?
No, there's only...
1, 2, 3 bonds, right?
Is it the amount of bonds or the amount of C it's connected to?
The amount of speed is secondary.
Let me think about that for a second.
No, I'm pretty sure it's tertiary.
I want to say it's tertiary too.
Then number 2 is
No, number 2 still tertiary. It's got 3 carbons. That's a really good question. And I'm going to be honest, I just second-guessed myself, which is very rare. Say that again?
I don't think you've ever given us one with a double bond before.
Is that what it is? I'm going to go look this up because I don't want to screw this up, because now I literally just second-guessed myself. Does anybody remember what chapter that was in? Was that 12? That was last chapter, right?
Yeah.
I got my book out. I'm just, yeah.
So I googled it, and they're saying how many carbons it's bonded to, not how many bonds it has.
So that would be secondary.
It's on page 431 in
Yep.
the book.
Yep. And was that you, Hudman? That's funny, because they never once. That's crazy. Yeah. So, Hudman, was that you that said I'd never given you a double bonded one?
Yeah.
Yeah, you know why?
Why?
Because never once in the book do they give a double bonded one. Which is why I taught it that way. So you're right. Let's just do this. Let's pretend that double bond's not there. And then that will go to make that a what? Now it's a secondary. Yeah, I just noticed that. And I don't know if maybe I subliminally, when I taught that, knew that or what. But yeah, you're right. They never did that with a double bonded one. So, go figure. Okay? Alrighty, so that is that part. Okay, now, one thing I will say, functional groups. Now, I don't know what to do here, to be honest with you. I realize you get a double-sided 3x5, but I am not sure how much space I would devote to those functional groups. Anybody remember what I'm talking about?
Yeah.
Yeah, this is page 403 and 405. I would try to find a way to kind of narrow that down a little bit, simply because I just don't think there's a need to devote too much space on my card to that. Does that make sense?
Yeah.
So try to find a way to narrow that down as much as you can. Because if I recall, when I taught this, I suggested you fold your 3x5 in half and devote half that card to those functional groups, right? Well, if we did that, that means you'd be devoting 1/4 of your 3x5 to one question out of 80. That's just stupid. You see what I'm saying there? So, I don't know. Maybe do a better job of memorizing a few of them or something. Okay? We good there?
Yeah.
Okay. Alrighty. So, let's see. Okay, so they go review really quick as far as there's really no order here. So if I were to ask you this, let's say I gave you this, and I were to ask you, is there a problem with that compound?
Yes.
What?
Yeah. There's a carbon with 5 salts.
Okay, yeah. Not possible. Okay? So here's a question like that. Okay? Alrighty, now they're going to do this. Okay, let's say I give you that. Let's go raisey handy. Name that sucker. And let's go for 12. Count me to 12. Name that compound.
One. 2.
Three.
4. 5.
Seven.
8.
9. 10.
11.
What did I say? 12, right? Not gonna get there?
What number are we on?
I thought we were on 12. Going to 12. And we'd gotten to 11, I thought. You're 12?
Yeah.
Okay. Alrighty. Who was number 5?
That was me again.
Who was number 6?
That was me.
Okay, so where did you start numbering?
On the very left side.
Right here?
Yeah.
So you went 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
Okay, so no matter what's this going to be? Octane, right? I got octane going on here. So at my third carbon I have what? I've got an ethyl. At my fourth carbon I have a what? I've got a dimethyl there, but then I've also got another methyl there, so I actually have a trimethyl, right? So because E comes before M, what do you name me?
3-ethyl -4,4,5 -trimethyl octane.
Is she right?
Yep.
Yeah, great job. Great job. Is that you, Russell?
Yeah.
Good job.
Why do you have to do 2? Okay.
We good? What?
Can we do another one of those?
Can we do another one? Is that Eliza?
Yeah.
Hey, I saw your sign this morning.
My turn? Oh.
Your son. Because I like drive by your house every day. Sometimes multiple times a day.
Oh, creepy.
She lives on the way to school. Sorry. I didn't.
I think everyone passes my house. So,
Say that again?
I think everyone passes my house during school.
Well, I would say at least half, because the other half come up 4,700, but yeah. So, did somebody want to do another one?
Yeah.
Oh, okay. So, let's kick this up a notch. Wait a minute, one more. Let's do that. Just because I can. Alright, let's I don't know, let's go to 15 here. And this is challenging. This is one of the harder ones I've done. But we're done for today, so let's see what happens here.
One.
3.
4.
5. 6. 7.
8.
9.
10. 11.
We're still at 11, right? Anybody get past 11 yet? Okay. Was that a 13?
Yeah.
Okay. Not gonna make it? Alright, well we gotta wrap this up. So, who is number 7?
I was.
Okay, so where do you want to start?
At the NH2.
At the NH2 is where you want to start numbering it?
Yeah.
Okay, why?
Because it's an aniline.
It's an aniline. So, who am I talking to?
Corinne.
Corinne, nice job. So, I'm going to start here. So, that's going to be my 1, because that's what I'm going to name it. I'm going to name it aniline because of that NH2, right? Which way am I going to number this?
Across the double bond.
So, I'm going to go 1, 2, 3, 4, 5, 6. Now, she's right, because that gave me that as a 2. Anybody know an exception to that? Anybody remember anything that was about that might cause us a problem?
If there's a closer branch on the other side.
Exactly. If I hadn't have put that there, I would have gone that way because I would have made that a 3 instead of going the other way and making it a 4. But we're good. So we're here to aniline. So then what do I got, Corinne?
There's an ethyl on the 2.
So I got an ethyl there.
A butyl on the 4.
Butyl on the 4.
And a propyl on the 5.
Propyl on the 5. Good job. So now I can pretty much name it, right?
Yeah.
So what do you got?
4-butyl.
4-butyl.
-2-ethyl.
-2-ethyl.
-5-propyl aniline.
Is she right?
Propyl cyclohexane.
Oh. Which is it?
No, because aniline includes that it's a benzene ring.
Bam, nice job. Right? Because we went bases aniline, you're right, it included that, and that was its given name, so I would have been alright without the cyclo. Good job, Sierra. Good job, Corinne.
Thanks.
So, all these ones that were recalling homework,
Okay?
we hadn't put the 1 when it was at the, like, in the middle of it and not at the beginning.
Now say that again.
So, it made me do 5-propyl-1-aniline, because it didn't start with aniline.
That is weird. Because I believe when I taught this, we always started numbering it what made it what it was, right, Corinne? And that's why you went aniline, and that's why you put a 1 there, correct?
Yeah.
And I believe if that's what you name it, it's understood that that's where the 1 goes. I tell you what, Camby, was that you?
Yeah.
Is there any way you could find that question and send it to me?
Yeah.
So I can look at that? Yeah, I just don't want to make a mistake there. But here, you're going to be fine doing, we're good here. Okay? But do send that to me so I can go back and look at that. So I want to make sure I'm not teaching something incorrectly. But I'm pretty sure that's correct.
I have a question.
Yo!
So, you don't have to go across the double bond if there's a...
Okay, so there was, and correct me if I'm wrong here, Tolman, but there was one question where, because we've had a couple of rules that superseded others, right? And in that situation, the sum would have been less had I not gone across that double bond first. And if you go back, some rules.
Okay, I thought you had to go across.
Well, you typically do, unless I'm going to get a lower sum going the other way.
Okay, thank you.
And that's why I did that. The rules kind of built on each other, and you're right, there was a little gray area there, which is why I put that Ethel there to kind of keep those rules in place. Does that make sense?
Yeah.
So yeah, they do not go that complicated on the test. I just wanted to see what we could do, and I was mildly impressed. So good job. Okay. Alrighty, we have used our time for today. I do not want to go past an hour. We're over 50 minutes. So unless there are any pressing questions, I want to wrap this up. Anybody got anything?
Is the test at 10 a.m.?
The test is going to be at 10.
And then is it 2 or 3 hours?
I'm leaning towards actually 2.5. I'm getting a little bit of pressure from above on this. I got my one professor's going 2, my other professor's going 3. I don't know. I mean, I might push it to 3. My problem is that there's another test at 1. Right? Isn't there another test at 1?
At 12 too.
What?
There's a medical terminology test at 12 also.
Oh, there is. Okay, so do we want to bump it to 9?
Does that mean you do the review at 8? So could we do like 9 to 12 though if we did it at 9?
Yeah, we could do that. I'm going to be honest, I probably wouldn't do a review that day because I didn't schedule a review that day because do you think we're covering too many questions a day here? Now, I think it's working out about perfect, and we'll be done by then. So I really don't think we need it. I mean, we could go like 20 minutes, just a quick one. But I teach my math class at 8. So we could go at like 8:30. Go from 8:30 to 9 and then take the test at 9. Do you want to do that? So let's do that. So that's on the 15th. So 4/15 of 2020, we'll go class at 8:30, test at 9. That work? Just for any last minutes? Okay. You guys have a good one. Okay?
Life 15 of 2020?
What?
Isn't that 5?
Shit, sorry, who was that? Thompson, great job, Thompson, thank you. That is 5/15 of 2020. I appreciate that. That would have jacked us up. I'm inventing a time machine. We're going back in time. Okay, we'll see you guys later.
Thank you.
Thank you.
Thank you.
Yep.